We are going to discuss that how we can find the curvature of the smooth curve in 3 dimensions, in 2 dimension, in 1 dimension, in simple curve. So here we start from a 3-dimensional case where we given the vector value function f of t I plus g of t j plus h of t k. C is in the domain of the function. And we have the formula for that one as we discussed before, that our curvature is equal to t dash of t over r dash of t. We take magnitude of this one, both are the vectors. And we can write this formula in terms of r. We can derive it, this r dash of t cross product with r double dash of t, magnitude of this, because cross of 2 vector is a vector, we take the magnitude, divided by r dash of t, magnitude of this one to power 3. So this is the main formula for find the convergence in 3 dimensions. And from this formula, we can derive the formula for 2 dimensions and also for 1 dimensions. So here when we take the curvature in the case 1, curvature of the curve in 2 dimensions, we take the function r of t is equal to f of t I plus g of t j plus 0k, because we have x equal to f of t and y equal to g of t. We have this curve in 2 dimensions. Now we find r dash of t. When we find r dash of t, so r dash of t is equal to, now we take the derivative of this one, this is equal to f dash of t I plus g dash of t j, and again we have 0, derivative of 0 is 0k. Again find r double dash of t is f double dash of t I plus g double dash of t j plus 0k. Now we take the cross product of these two to substitute in the formula. This r dash of t cross r double dash of t. So the formula is the determinant I j k, then derivative of this f dash g dash and 0, and we are having f double dash g double dash. We take derivative with respect to y, and we open this one. So we are having I multiplied by 0 minus j multiplied by 0. We have the k. With k we are having here f dash g double dash minus g dash f double dash. Our only component, this is our k. When I take the magnitude of this one, this r dash of t multiplied by r double dash of t. So we are having here 0 plus we are having here f dash g double dash minus g dash f double dash whole square whole under the root. So when you simplify this one, we get here, this is the f dash g double dash minus g dash f double dash. So this is the result we'll get. This value is always positive. Curvature is always positive when we take, because we are taking the root sign. So root is the value of root and become always positive. So we keep it as positive. So this is my one value. Then we need the r dash of t. So my r dash of t, we take the this f dash of t whole square plus g dash of t whole square whole in the root. This is my magnitude of the vector r dash of t. Now we substitute to find the curvature. The curvature is equal to r dash of t cross product with r double dash of t over, we are having here r dash of t to the power 3. So we are having this equal to, the result is f dash of t g double dash of t minus g dash of t into f double dash of t. We take magnitude of this one, this magnitude, and this here is r dash of t and to power 3, and then we having here root of this one. So this become here 3 by 2. So this is my result for finding curvature. Now I take the second case. My second case is that we are having here the function given to me. Find the curvature of this function. Find curvature of the equation y equal to f of x. Now I just write in a parametric equation. We take x equal to t and my y is equal to f of t. If I write my curve, and my z is 0, obviously in this case, so my r of t is equal to ti and plus we are having here f dash of t j plus 0k. Then I find here r dash of t. So my r dash of t is equal to I plus, here is no dash, this is only here simply. Now we are having here, take the derivative we get here f dash of t j plus 0k. I find here I double dash of t. My I double dash of t is 0I plus f double dash of t j plus 0 times k. Again, we use our formula, we find r dash of t cross r double dash of t, that give me here I, j and k. My r dash is 1, f dash and 0. My r double dash is 0, f double dash, and here is 0. I open this determinant, I 0I minus j, again 0j, and with k is f double dash of k. Now again I take the magnitude of this one, r dash of t cross r double dash of t. Magnitude of this one is root of 0 plus f double dash square of this. So when I take here, I have here now f double dash of t magnitude, because this must be always positive. We are taking root of something, the root of something we take must be positive. Now we find here r dash of t magnitude. We have the vector r dash of t. We take the magnitude of this vector. Magnitude of this vector is 1 plus f dash of t whole square under the root. We can see here, we can find here my f of t is y. So when f of t is y, so I can write here y double dash. F of t is y, I can write here root of 1 plus y dash square. So as I say here, because I have taken y is equal to f of t. Now I use my formula and I can find my curvature. My curvature is r double dash of t cross r dash of t, r double dash of t over r dash of t. Now I substitute the values. I have just calculated. I can have here, this is my y double dash, magnitude of this one over. I am having here r double dash is I plus 1 dash whole square. Root of this one, power 3 here. So it's become here 3 by 2. So I have the formula, if y is equal to f of x, then we have the curvature of this one is equal to kappa is equal to y double dash over 1 plus y dash whole square power 3 by 2. I can show with an example the application of these two formulas, and we'll discuss the application of the formula for the curvature in 3 dimensions. We're going to discuss the acceleration components, the tangential and normal, and there we're using r dash, r double dash, and also we'll do the kappa here. Already we have 3-dimensional case, we have discussed the curvature by finding t dash and r dash, and that is t dash magnitude over r dash. So we use that formula here. I will give you some examples where we are going to apply the formulas for finding in 2 dimensions the curvature, and in the case of y equal to f of x.